All right, and this is called arc measure. Did everybody get turned in what the assignment was for when the sub was here? If you're at home, you can just post that, go to the assignment, and you should see a place where you can submit it. Take a picture. It's best if you scan the picture. Most phones, you can get a scanning app. Scan the picture and do an add page. That way, each page is not its own separate document. So like say you're turning in 5 pages. If you turn in, if you don't scan them and do add page, then you have to literally add 5 separate documents. But if you scan it and you just keep doing add page so that it's all one document, it uploads much easier and I can grade it much faster. And also, for me to visually see the assignment, it turns up so much brighter and clearer when you scan it as opposed to use it just taking a picture. But sometimes it's really hard for me to see. If you're home on quarantine, you can also wait till you get back to turn in your work, but it'd probably be easier just to keep up with it while you're out and instead. And I know those of you who are regular e-learners, I am a little bit behind on your grades, but I will be working to try and catch that up. Okay, so my apologies there. All right, our target today. Describe how to determine the length of an arc of a circle. Also, describe how to determine the measure of a central angle of a circle when given the arc length and radius. All right, so this really takes you back to geometry. A lot of geo stuff going on here. And you probably pretty much learned this in geometry, not that you remember it from back then, but hopefully it will seem familiar to you. The first thing it says, or the first thing we're going to write is we're going to figure out what an arc is. Y'all remember what an arc of a circle is? Yes, no, maybe. Okay, well, an arc of a circle is a portion of the circumference of a circle. An arc of a circle is a portion of the circumference of a circle. So I'm going to draw a circle. We're good at drawing circles these days. And in the center of my circle, I'm going to put a point, and I'm going to label it point Z. And I am going to draw a line segment that connects Z to the circle. And that point where it connects, I'll call that point T. T as in Tom. And then, or I could call that the radius. And then I will draw another radius from Z to a point on my circle. And I'm going to call that point M. M as in Mike. So I have created an arc. Arc MT. Arc MT. This is how you denote it. The little arc and an MT. I know at home y'all can't see that yet. And a lot of times we use a lowercase s to symbolize an arc. So if I'm talking about arc MT, that is just a portion of the whole entire circumference of a circle. Just a portion of the circumference, okay? And if I want to talk about the arc that goes the other way around, like the larger portion of that arc, usually you would need another variable or letter out there. Usually you would use 3 letters, so you would know like if you were going the other way around, okay? So let me write the length of an arc. The length of an arc is the length of its portion of the circumference. We usually use lowercase s to symbolize arc length. I know there's going to be like a lot of words in today's lesson, but if we don't write the words, a lot of times it's hard to know what you're talking about when you go back and reread your notes later. All right, consider the diagram below. Where theta equals 45 degrees. And the circumference is 80 millimeters. Also, we need to write that the word subtend, I can't remember if it was with this class or my second period, where somebody was asking me what subtend meant. The word subtend means to be the opposite of. In this diagram, if we say angle theta subtends S or arc ST. I didn't mean to say if we say. In this diagram, we say angle theta subtends S or arc ST, which we haven't drawn the circle yet, so you're like, what diagram is she talking about? So I'm going to draw a circle. I'm going to try to draw what looks like a 45-degree angle. That's my theta. I'm going to label that arc ST. So what we're going to do is we're going to try to figure out, okay, well, what is the length of the intercepted arc? So we would say that arc ST subtends the 45-degree angle. It's the opposite of the 45-degree angle, okay? So to find the length of an intercepted arc, multiply the circumference of a circle by the ratio of the central angle to 360 degrees. Good. Sorry. Okay, so let's figure out what that circumference is, or I'm sorry, the ratio is. So our angle is 45 degrees out of how many total degrees in a circle? 360 degrees. So that ratio is a fraction, looks like a fraction. So 45 out of 360. Now you could multiply that by the circumference, 45 over 360, or you can probably just reduce it if possible, so that way your number's not going to be so giant. Does anybody know what 45 360th reduces to? 1 what? 1/8. Very good. 1/8. So 1/8 is my ratio. 1/8 is my ratio. So to find the length of the intercepted arc, it says multiply the circumference of a circle by the ratio. Multiply circumference by the ratio. Well, what did it tell me that the circumference was? We wrote that above in the blue. I should have rewritten my directions, but what did it say the circumference of this circle is? 80 millimeters, right? So 80 millimeters times our ratio is 1/8 equals, wouldn't that be 80 millimeters divided by 8, which is what? 10 millimeters. So if the circumference around the whole circle is 80 millimeters, since this is a 45-degree angle, that 45-degree angle is 1/8 of the circle. So 1/8 of 80 millimeters is 10 millimeters. Well, that does not seem too difficult. All right, so, but we're gonna have to find other things too. Anybody have a question on that or still copying? Okay. All right, next page. We have a formula to help us find the measure of a central angle. We have a formula to help us find the measure of a central angle. So that formula is to find theta, you take the arc length and divide that by the radius. So S stands for arc length, or doesn't stand for, it's what we use to represent arc length. And R is what we use to represent a radius. And you know that little symbol I drew is your theta. All right, so that's our formula that we're going to use to help us find the measure of a central angle. Or you could also, if they gave you the angle and the radius, you could find the arc length. Or if they gave you the theta and the arc length, or I already said that, theta and the radius, you could find the arc length, whatever. So it doesn't just have to be used for the measure of the central angle. But the way it's written right now is to find theta, take the arc length divided by the radius. So let us look at an example. Find the length of an arc. Find the length of an arc subtended by a central angle at 315 degrees in a circle where the radius is 20 inches. So we know, I told y'all that in trig, we usually don't deal so much with the degrees anymore, right? They did ask us of the length, and they gave us the degrees, written as degrees, not as radians. But we are going to first convert the degrees to radians because that's generally what we deal with, okay? So first, we will convert the degrees to radians. So we know to do that, we take our degrees, and since degrees are in the numerator, we're going to put degrees in the denominator and radians in the numerator. So in the denominator, I'll have 180 degrees, and I know that's equivalent to pi radians. So let's see, I know my little degree symbols, either the word or the symbol will reduce or cancel each other out. And I'm going to go ahead and reduce 315 and 180. I know, let's see, I think I can divide by 45. 315 divided by 45 is 7. And 180 divided by 45 is 4. So what I'm left with is, in my numerator, I have 7 pi radians. In the denominator, I have 4. Or we could just say 7/4 pi, okay? Because I'm not going to write the word radians in my formula. So now we're going to go and substitute that into the formula that they gave us above for theta. So now substitute 7/4 pi into the formula for theta. Because that is my angle measure, right? In radians. So we know that the formula is theta equals the arc length divided by the radius. We know that the arc length is 7/4 pi. And we're going to set that equal to. We do not know the arc length. Make sure your S looks like an S and not a 5. And they did tell us in the problem that the radius was 20 inches. Okay. So now I need to solve this. I could either find the cross product, or I can multiply both sides by the least common denominator. All right. Probably finding the cross product is simplest. A lot of y'all say you cross multiply, but there's no such thing as cross multiply. It's cross product. That's when you multiply the numerator of one fraction by the denominator of the other and vice versa. You can only do that when there's an equal sign. If you're multiplying two fractions together, you do not find the cross product. That's numerator times numerator, denominator times denominator. But if there's a fraction with an equal sign in between, then you can multiply the cross product, okay? So 7 pi times 20 would be 140 pi equals 4s. And then what? And then what? Have we solved for s?
Divide by 4.
Thank you. Somebody at home. Divide by 4. So I'm going to put the s on the left. S equals 140 divided by 4 is 35 pi. Now here's the thing. When we are talking about arc length, we do not say arc length in terms of pi, okay? We say angle measure in terms of pi. So was our theta in radians or degrees? What? But we converted it to radians. So if we don't want to state this in terms of pi, which arc length you don't, we're going to make a note about that. You think I would substitute 180 in for pi or 3.14? 3.14. If this was in degrees, I would do 180. But it's in radians. Our arc length was in radians, so we'll do 3.14. Let me make a note of that real quick. We do not write arc length in terms of pi. So since theta was converted to radians, substitute 3.14 in for pi. So that would be S equals 35 times 3.14. Multiply that together, and I'm going to have to round. So my arc length is approximately 109 and 9/10, that was in inches, because the radius was in inches, so we know that our circumference is also in inches. All right, you cool with that? Anyone have a question? Comments or a concern? Okay, thank you. Page 3. No, not page 3. Yeah, page 3. And page 3 is my last page. No longer putting because if you're out, I really want you to watch the video. And I know the video gets very aggravating because it's so glitchy. I get it. However, you're still going to learn a whole lot more by hearing the explanation instead of just trying to copy the notes and just hit button. Okay, because a lot of you aren't trying to comprehend what you're writing as you're writing it. And so it really doesn't do you any good. So as annoying as it is to watch the glitchy video, it will be the best thing for you. Does that look a little fuzzy or does it look okay? A little fuzzy? Uh-oh, it disappeared. There it is. Okay. That look better? Okay. Next example. Find the measure of the central angle with a radius of 3 centimeters that subtends an arc of 2 pi centimeters. Okay, so our formula, theta equals arc length divided by the radius. And they told us that our arc length is in 2 pi. Now again, generally we don't write the radius in terms of pi. So if we were given our answer, we would want to fix that, but that's okay. So we have 2 pi divided by 3. But is it okay for us to find that angle in radians? Our angle measure we want in radians, right? So basically, is there any math to do here after we've substituted into our formula? No, our arc length is 2/3 pi. So this would be our answer in radians. But what if we wanted to write our answer in degrees? What could we do? Say it again. Now, 3.14 means radians. 180. So if we wanted to just write this not in terms of pi, but leave it in radians, put it in radians in decimal form, we would put in 3.14 for pi. But if we want to write it in terms of degrees, and so I'm just going to, that's why I'm going to keep like kind of doing both so you remember like, oh wait, that's radians for degrees. So if you want to state in degrees, yes, you could convert by 180 degrees divided by pi radians, but if it's in terms of pi, super easy. All you have to do is substitute 180 degrees for pi. Soup's easy. So theta equals 2 times 180 equals 360 degrees. Divide that by 3 and you get 120 degrees. So in degrees, it's 120. In radians, it's 2/3 pi. They didn't tell us what way to leave it, so we just left it both ways. Y'all cool with that? Now let's do everybody's favorite word problem. I know how much you love them. But this is a really good like SAT, ACT question. I know when I was helping my stepdaughter get ready for the ACT, there was a lot of trig stuff on there, radians and all that mess, and sine, cosine, whatever. And it doesn't get deep into it, but at least probably what we will learn in this class, you'll see a lot of that on, I know the ACT. SAT, I'm assuming, but I'm more familiar with the ACT. All right. It does have trig on there. I wouldn't say a lot, but on the review, I mean, it had several trig type questions on there. Okay. All right. Lizette and Aliani. I did not make these names up. I got this example out of the book. Are running a relay race. The circular track, now y'all know tracks aren't usually circle, they're more of an oval, right? But in this case, it's a circular track on which they are running has a diameter of 60 meters. What's a diameter? Exactly, it goes from one side of the circle to the other through the center, right? So it's twice as long as the what? Radius. So what would the radius be? Very good. Aliani is positioned 89 degrees from her teammate. How far will Lizette have to run before passing the baton to Aliani? All right, so let me read it again. Lizette and Aliani are running a relay race. The circular track on which they are running. So I know I have a circle here, right? The circular track on which they are running has a diameter of 60 meters. Aliani is positioned 89 degrees from her teammate. So I'm going to put Lizette down at 0 degrees. And I know Aliani is 90 degrees from there. So I know that's just a little bit less than the 90 degrees, right? How far will Lizette have to run before passing the baton to Aliani? So Lizette is down here. She's running along the circular track. She's 89 degrees from Aliani. What is it that we're going to have to find? The arc measure, right? Do we know theta is what? 89 degrees, which we can convert to radians. Do we know the radius? 30, right? The diameter was 60, the radius is 30. So, and I mean, it's really not necessary to convert it to radians first, but since we're doing trig, we're going to convert it to radians first, okay? Convert to radians. So we know that would be 89 degrees times my conversion, since degrees will be in the numerator. In the denominator, I'll put 180 degrees. And the numerator is pi. You don't have to really write pi radians. Technically, yes, but. So 89 degrees times pi over 180 degrees. We know the degree symbols cancel. And I don't believe you can reduce 89 and 180. So that would just be 89 pi over 180. No degree symbols. Okay, so now we're going to take that and plug it into our equation. Theta equals the arc divided by the radius. So theta equals, or no, I didn't mean to write that. My theta is 89 pi over 180. That's what I meant to write. Let me just cross this out. 89 pi over 180 is my theta. I'm looking for my arc, so I'm going to leave an S in the numerator. And my radius is 30. So I'm just going to find the cross product. You could also multiply both sides by the least common denominator and get rid of the fractions that way. But I just feel like the finding the cross product is easier. So let's see, 89 times 30 is 2,670 pi. And S times 180 is 180S. Divide both sides by 180. So 2,670 divided by 180 is approximately 14 point, I'm going to go 14.83 pi. Don't forget your pi, and that equals S. We know arc length, we don't leave that in terms of pi. We do not leave arc length in terms of pi. So was our theta in degrees or in radians? We converted it to, it was originally in degrees, but then we converted it to radians. So in our formula, we used radians, right? So we don't want to write this in terms of pi. So would we substitute 180 degrees for pi or 3.14? 3.14. If we had stuck with the 89 degrees, then we would substitute in 180 for that. But we didn't. We turned it into radians. So 14.83 times 3.14 gives me my arc length. So arc length is approximately, I'm going to go with 46.6. 46.6 what? Meters. Coolio? All right, so for your, I'm going to give you the assignment tomorrow, okay? Take our notes today. We'll do our assignment tomorrow. And then, so technically, you are finito. Coolio? All right. So everybody at home, feel free to log off. Make sure that you submitted what was assigned when the sub was here. And then we will see you back tomorrow here in class.
Have a good day.
What's that? Oh, okay.
Miss Riley,
Mhm.
I think it might be test Saturday. Do you have any like recommendations for what I can study for as far as math goes?
I would get a study guide. Our library, I think here, the PHS library, I believe they have them that you can check out. You can buy them too, but they're not cheap, but you ought to see if they have them.
Okay.
If they're even checking out books, I don't know if they're or not. Well, hey, I'm trying to do something that administrators need for me to know like ASAP. Sorry. Not trying to blame you all.
I'm really happy that I do well on that math ACT because I'm like 2 points away from getting everything I need to keep on doing on
I hope so. You need that to be going on.
You have to have, well, they can plug in for their FERT scores, and my freshman year is when I took my FERT test. So I was still shaky on some of the math stuff, and I had passed my reading and my writing, and they're like, oh yeah, you have like 3 attempts every year. Well, I asked my guidance counselor before. I said, do I need to take the ACT? Do I need to go ahead and take the FERT? Like, you will take the FERT this year so I can keep doing my college second semester. And she's like, oh yeah, you're fine. And then I went to like make my ACT plans because like fall was really busy, but I knew in December I'd be able to take it. And so I went in, and my college counselor was like, you don't have your math score, which none of my classes had anything to do with math. And she was like, so you're just going to be able to take like psychology and this class, and the rest of them you have to put a hold on until, because I went to take my FERT, and they're like, you're maxed out for your 2 years. You only have 2 attempts. Yeah. So I'm trying to take my ACT. Yeah, I'm trying to take my ACT this semester and get passing my scores, which shouldn't be a problem because I'm also trying to get it from my bright teachers. So it kind of like takes 2 birds out with 1 stone. And once I get done with this semester, or during the summer, I'm going to finish up what classes I need to get my prerequisites done.
Oh gosh.
Yeah.
Well, yeah, I would go Lowry first and see if they have that, and then if not, you can get it. I know I bought it on Amazon.
I'm pretty sure I saw one on Amazon. Somebody else, I mean, took the ACT. Not a lot of people have, but I figured it would be a lot easier because they said it's just better as far as reading goes, which I'm a little bit stronger in reading than I am. I'm not terrible at it, but just trying to make sure that I get the scores I need.
Right. Well, let me know if you need anything. You're welcome.